So how many of you can quickly restore a Kubernetes cluster in case of a disaster, or spin up identical Kubernetes cluster in another data center or even another cloud provider? Or instead of doing risky in-place cluster upgrades when migrating from Kubernetes version A to B, you can instead create a new Kubernetes cluster with the new version and migrate your workloads across. Today we're going to be taking a look at achieving all these outcomes with a tool called Velero. Velero is a lightweight tool that runs in your Kubernetes cluster with the sole purpose of making backups of objects in the cluster. It can target all sorts of Kubernetes objects using labels, so you can back up only certain objects or entire namespaces. It can also make backups of data inside persistent volumes. So to start off with this video, the first thing we're going to need is a Kubernetes cluster. And for that, I'd like to use a popular utility called Kind, which allows me to create disposable Kubernetes cluster in Docker containers that I can use for testing. So to create a Kubernetes cluster, I say kind create cluster, I give it a name Velero, and I run Kubernetes 1.17. If I go ahead and run that, that'll start creating a Kubernetes cluster within Docker. This will create a lightweight disposable container that we can throw away when we're done. So if we take a look at the source code, I have a Kubernetes folder, and inside the Kubernetes folder I have a Velero folder, and in here I have a README. This README highlights all the steps and commands we're going to be taking a look at today. So be sure to check out the links down below to the source code so you can follow along. So now that we've deployed a cluster, I can say kubectl get nodes, and we can see we have a 1-node Kubernetes cluster up and running. So let's deploy some example applications to it. Now in my GitHub repo, I have a Kubernetes folder, and I have a couple of examples we can deploy. I have a config map, I have secrets, I have a deployment, and I have services. So I can say kubectl apply, and I can apply the config maps in the Kubernetes config map folder. I can apply an example secret, I can apply an example deployment, and I can apply an example service to expose the deployment. This will create 2 pods of my example deployment. It'll create a server to expose it, as well as a config map and a secret that's mounted to these pods. I can then access that example application by saying kubectl port forward to that example service on port 80, and I can go to the browser and we can see we have our Hello World application up and running. So now we can simulate a real life scenario about having a Kubernetes cluster with some workloads running on it. Now in our first use case, let's set up an automated daily backup of our Kubernetes cluster. And in our second use case, let's upgrade from Kubernetes 1.17 to Kubernetes 1.19. And I'll show you how we can use Velero as part of the process to take automated and manual backups and restore it to our clusters. Now we've completed the first step of creating a Kubernetes cluster. Now for demo purposes, I like to do everything in Docker containers because it's an easy way for me to install stuff inside of a container so that I don't have to install things on the host, and it also makes it very reproducible. So what I'm going to do is I'm going to run a small container saying docker run -it. I'm going to mount in my home directory because that's where my kubeconfig file lives, so I can access my cluster. And then I'm also going to mount in this entire GitHub repo, and I'm going to run a very small lightweight Alpine container. Next up, I'm going to go ahead and install curl and a lightweight text editor, and we'll use curl to download Velero and all the tools we need. So the first thing I'm going to do is download kubectl using curl, give it execution rights, and move the binary to user local bin. I'm then going to set my editor to nano, and now I can go ahead and I can say kubectl get nodes, and we can see we can access our 1-node Kubernetes cluster from the container. Now Velero has a pretty good website with documentation on how to download and install it. I find the easiest way is to head over to the Velero GitHub page and go over to the releases section, and you can go ahead and download the release straight off the releases page. And they have all the binaries for different operating systems, including Linux and Windows. So because I'm running in a lightweight Linux container, I'm going to go ahead and grab the 1.5.1 release using curl, and I'm going to download the Linux binary. So it's very simple. I just say curl, I download the tar file, and then I go ahead and extract the tar file, and then I go ahead and inside that extraction I just move the binary Velero into the user local bin. I give it execution rights. And to test this, I can say Velero --help. And we can see Velero CLI is now installed in my container. Now with the Velero CLI installed, we can go ahead and install all the Velero components to our Kubernetes cluster. That's the easy part. Now before we go ahead and install Velero, we have to set up the storage of where Velero will be sending the backups to. Velero supports a range of different providers. So if you're running in Microsoft Azure AKS, you might want to use Azure Blob Storage. If you're running on Amazon EKS Kubernetes, you might want to use an S3 bucket. The same thing goes for Google Cloud and a bunch of other cloud providers. In this example, I'm going to show you how to back up to Azure Blob and AWS S3 buckets. So if you head over to the Velero documentation and you go to the plugins section, you will see that Velero supports a wide range of plugins, different cloud providers and different storage solutions. In this demo, we'll take a look at Amazon AWS and Microsoft Azure, and all these plugins will point you to GitHub repos, so all the code is open source. So let's go ahead and create an S3 bucket and an Azure Blob Storage. Now for that, in my GitHub repo, I have the Kubernetes Velero folder. The README is over here, and in the next step of this README, we're going to go ahead and create storage in both the cloud providers, and I have separate little MD files that show you how to do so. So if we scroll down, we can start with Azure. That'll point you to the Azure MD file, and we're going to start with a new terminal. Now it's really easy to interact with Azure. We're going to run the Azure CLI in a Docker container. I say Docker run, and I run the Azure CLI 2.9.1. That's going to go ahead and download the Docker image and give us a terminal where we can start running Azure CLI commands. Once it's finished pulling that image, we're inside the container, and we can go ahead and run AZ login. This will give us a link with a code, and we can go ahead and follow the prompts and log into Azure. So once we've logged in, we can go ahead and create our storage. Now to do so, there's a few environment variables that we need to set. So the resource group where we want our storage located, the Azure storage account name. We also want to set a blob container name, as well as our subscription ID. So I go ahead and set my subscription ID, and I'm going to define all these other environment variables. Then before we create the storage, we want to make sure that our default subscription is set. So I say AZ account set, and I go ahead and create that resource group. So I say AZ group create the resource group name, and location is West US. And now that we have a resource group, we can go ahead and create our storage account. So we say AZ storage account create, we pass in a name and a resource group, and we just use the standard GRS SKU. Now that we have our storage account and key, the next thing we want to do is create a blob container. So I say AZ storage container create, pass in the name of the blob container. We turn public access to off. This is important because your backup can contain secrets and you don't want your backups to be publicly accessible. Then I pass in an account name and the key. So that'll go ahead and create a blob where our backups will be sent to. Now all the information to authenticate with that storage account is in environment variables. Now what we want to do is we want to take those environment variables and set them in our Velero container. So what I've done is I've created a print statement here. If we copy that and we paste that to the terminal, it'll output the export commands for the environment variables we need. So the blob container, the backup resource group, the storage account name, the storage account access key, and the subscription. We need to take these export commands, copy them, and go to our Velero container and set them. This will allow us to use these environment variables during the Velero install process. So now that we have our storage set in Azure, the Azure folks are happy. Now for the AWS folks, let's go ahead and create an AWS S3 bucket for our backups. So for Amazon, I have a separate link here for the Amazon storage, which you can find in the Velero folder, AWS MD. And for that as well, we're going to create a new terminal. And what we want to do is run the AWS CLI. So I'm going to say docker run -it, run Amazon AWS CLI 2.055. That's going to go ahead and download the Amazon CLI Docker container and give us a terminal so we can talk to Amazon using the CLI. Now, when dealing with the Amazon CLI, it likes to use JSON output. So what I'm going to do is I'm going to say yum install, and I'm going to install the JQ binary to work with JSON. Now to authenticate with Amazon, we go to the browser, we go to the Amazon Management Console, we click on our user, go to my security credentials, and I'm going to go over to access keys and create a new access key, which I can just use for this demo and delete it when I'm done. After we created our access ID and key, we can go ahead and log into AWS by saying AWS configure, and then we can just go ahead and follow the prompt. So it'll ask you for an access ID ID. It'll ask you for the secret key. I'm going to set my default region name to Southeast, and my output is just going to be JSON. Now, creating a storage bucket is very easy. We're just going to provide a bucket name. So I'm going to set that environment variable. We're going to set a region environment variable, and we're going to create a bucket saying AWS S3 API create bucket, pass in the bucket name, pass in the region, and the bucket configuration, which is just the location constraint on the region. So I'm pasting that to the terminal. That'll go ahead and create our S3 bucket. So now with our bucket created, one must note that there's a few ways to authenticate with Amazon. So if you take a look at the Velero documentation for each one of the providers, they're all going to have different options on how to authenticate. With Azure, we're simply going to be using the blob storage account key and name, but the Amazon folks provide two options on how to authenticate. So if you go to the Velero documentation, you'll see there's a bunch of Velero supported providers, and AWS is one of them. And the setup instructions is in a GitHub repo, which you can find over here. And you can see we've already created our S3 buckets, but there's two options on how to set permissions. One is to use a separate IAM user, and the other one is to use a thing called kube2IAM. So in this example, we're going to be creating a separate IAM user and set up the policy for that user to be able to access that S3 bucket. So the next thing I'm going to do in order to allow Velero to access that bucket is create a new user. So I say AWS IAM create user, username is Velero. I'm going to go ahead and run that. That'll create a user. So the next thing I'm going to do is set up a policy for that user. And in Amazon, everything is done through a JSON file. So I can create this policy in JSON and then bind it to that user. So the default policy for Velero is to allow it to create volume. So if you want to take volume snapshots and also work with S3 buckets. So we're going to give it this permission specifically to this bucket that we've just created. So what I'm going to do is create this JSON file using the cat command. And we can see if I do ls, we've created this JSON file now. And then I'm going to say AWS IAM put user policy, and I'm going to bind that policy that I've just created to that user that I've created earlier. So I go ahead and run that, and now our user should be able to access that S3 bucket. Now when we configure Velero, we're going to need to give it an access key for that user. So to do that, I'm going to say AWS IAM create access key for the user Velero, and I'm just going to spit it out to a temporary file called key.json. So I go ahead and run that, and if I print out this key.json user, we can see that we've created this access key. So now what I'm going to do is I'm going to set the access key ID and the secret access key from that JSON file into environment variables that I can use to configure Velero. So I say AWS access ID and I set that value. And then I say AWS access key and I set that value. That'll give us two environment variables we can use to configure Velero. Now, in order to configure Velero, we're going to need those environment variables set on the Velero container. So to do that, I have a little print statement, which if we run that, we can see that it'll give us the export commands to run inside the Velero container. So we're exporting the access ID, the access key, the bucket name, and the region name. So I go ahead and copy this, and then I go to our Velero container and export those environment variables. So now we're ready to install Velero and back up to S3 as well as Azure Blob. If you need further customization on these storage providers, feel free to check out the providers page. There's a link to the Amazon plugin setup GitHub repo, as well as the Azure plugin, as well as other cloud providers if you need to use them. So now that we have some storage, let's go ahead and set up Velero to back up Kubernetes to Azure Blob. Now, if you take a look at my README, I have the deployment process for Azure, as well as if you scroll down, the deployment process for AWS. Now, installing Velero is very, very easy and straightforward. Most cloud providers will firstly ask you to create a credential file. For that, we're going to use the environment variables we exported earlier. So what I'm going to do is create an Azure credential file saying cat, and I'm going to cat out the Azure storage account access key and the cloud name to a file. I go ahead and copy paste this, and we can see it creates a small file called credential Velero. I can print out that file using cat. We can see it's been created, and now we have a credential file to install Velero. So this is the install command. We say Velero install. We tell it the provider is Azure. The plugin is pointing to that GitHub repo, to a specific version of the plugin. Our bucket is going to be our Azure Blob container, our secret file, which is the connection to that blob, and our backup location config. Now this config is basically just a key value pair of a bunch of stuff. So we got the resource group, we got the storage account name, we got the storage account key variable that it needs to look at. So it's going to be looking for this variable, and a subscription ID. We also tell it to use volume snapshots as false. So in this example, we're just going to back up all the Kubernetes objects. So I go ahead and grab this and I install it. Now the first thing that this is going to do is create a bunch of custom resource definitions, which allows us to use kubectl to query backups and restores. It's also going to create a Velero namespace, service account stuff, and it's going to deploy a deployment to the Velero namespace. So this Velero install command neatly deploys Velero into its own namespace. We can see it's up and running by saying kubectl -n Velero get pods. The first thing that I highly suggest you do is also run kubectl logs command against that Velero pod and make sure that the logs are not throwing any errors. And your log file should look like something like this. So there's no errors being thrown. You can see the controller is currently verifying and checking the backup location to pull any existing backups into Kubernetes. Now, as you know, in Kubernetes, everything is already an object described by a YAML file. So we have deployments, we have pods, secrets, services, ingresses, and config maps. Now with Velero, we have two new objects, backups and restores. Now, when we first install Velero, it's going to go ahead and look at our provided storage and see if there are already backups that exist. And then what it will do is any backups that exist up there, it will go ahead and create backup objects in our cluster that we can list by saying Velero backups get. So it's important to note that Velero will not restore these backups by default. It'll simply import these objects into Kubernetes so we can list the backups that we'd like to restore. So let's go ahead and create our first backup. So creating a backup with Velero is very straightforward. We just run the Velero backup create command, and then we pass in a name of our backup, and we can pass in some extra fields. We can see those by passing in the help command, and there's a number of things we can do. We can exclude certain resources, we can exclude certain namespaces, we can include only certain namespaces or resources, we can even just query by label, so we can only back up certain objects using labels, and we can also back up from a schedule. So in this example, I'm just going to go ahead and back up the default namespace. So I say Velero backup create, I pass in a name, and I say include namespace default. So I probably recommend that you only update your namespaces for your applications that your teams use. So if I run that command, it's going to go and submit that backup resource, and then Velero will go and take that backup, and it takes a little bit of time to do so. So if I say Velero backup describe and the name of the backup, we can run that command and we can see that it has completed. So similar to kubectl describe, we can also describe these backup objects in Velero, and it'll tell us whether it's completed or whether there's any errors or warnings. It also told us that it included the default namespace, it didn't exclude anything. It tells you the resources that it included and excluded, any label selectors, and your storage location, which is pretty neat. It also tells you the started and completed time, so we can see here that our backup took 2 seconds to complete. And it also tells you the total items to be backed up. To list our backups, we can say Velero backup get, and we can see here that these are the backups that we currently have. And I can confirm by going over to the Azure portal to my resource group. I can go into my storage account, and I can go into containers. I can find that blob container, and we can see that the folder structure is here. And the cool thing about Velero is you can actually go into this folder structure, see your backups, and these are all little compressed files that you can go and uncompress, and you can go and inspect these backups. Velero also has a schedule command, so you can say Velero schedule, and you can pass in create, delete, describe, similar to a backup. So we can create a schedule to set up daily backups for our cluster. So if you want to set this up as a schedule, you can say Velero create schedule. You can pass in a cron syntax. So this will basically create a backup every 6 hours, and you can customize this cron syntax to create daily backups or hourly backups or however you like. Now, before I show you how to restore this backup onto a newer version of Kubernetes, let's go ahead and back up to Amazon S3 bucket as well. So because Velero targets a specific provider, I'm going to go ahead and delete Velero namespace, and let's reinstall Velero, but this time using the Amazon provider. So similarly to Azure, all providers would need a credential file. So we're going to say cat create a new credential file called credentials Velero, and we're going to pass in the AWS access key ID and secret access key for that IAM user that we created in our Amazon account. So I go ahead and paste that, and that'll go ahead and create this Velero credential file, which we can see over here. This will allow Velero to authenticate using that Velero IAM user. In the next step, we're going to say Velero install. This time we're going to say the AWS provider using the AWS plugin, and we're going to point the bucket to our S3 bucket variable, and our backup location config is going to be the region, the Amazon region where our S3 bucket resides. The snapshot location config is also pointing to that region, and the secret file that we've indicated earlier. So I go ahead and do that, and similarly it'll go ahead and install the custom resource definitions. It'll create the namespace, the service account, and create the Velero pod. And when we say kubectl get pods in the Velero namespace, we can see Velero again installed itself neatly into its own namespace. Then very importantly, as I'd mentioned earlier, we need to make sure we run the logs command against the Velero deployment to ensure that it's installed successfully and there's no credential errors. So if we do that, we can see that it hasn't detected any backups, and it's constantly checking for backups in that S3 bucket. So now let's go and test and see if that works by creating a backup. So we're going to say Velero backup create. We're going to create it with the same name as earlier, and we're going to include the default namespace. So that'll go ahead and submit a backup for Velero. It'll take a backup of our default namespace, which is all our stuff that we've deployed earlier. We can then say Velero backup describe and the name of the backup to see if it's successful or not. And we can see that command came back saying phase is completed, no errors or warning. It's done the default namespace. We can see it included all the resources. And again, this time it took 1 second to complete, and it backed up 13 objects. So if we go to the Amazon console and we click on services, we can go to the S3 storage section, and we can see we have our S3 bucket been created here. Similar to Azure Blob, it has a folder structure that we can go and inspect, the name of the backup, and all the compressed files are here. So you can go ahead and download these files, decompress them, and inspect them. So now that we have Velero and we have backups, we can use this as a form of disaster recovery, cluster migrations, or Kubernetes upgrades. And now that we have a Kubernetes 1.17 running, let's use Velero and deploy a Kubernetes 1.19 cluster so we can do a Kubernetes upgrade and use Velero to take our backup and restore our workloads onto Kubernetes 1.19. Now let's say we want to do a cluster upgrade and we want to create a new Kubernetes cluster with Kubernetes 1.19. So what I'm going to do is I'm going to say kind create cluster, and I'm going to call this cluster Velero-2, and I'm going to use Kubernetes 1.19. And now that that cluster has been created, I can go back to my Velero terminal and I can say kubectl get nodes, and I now have access to my second cluster. And if I say kubectl get all, we can see we don't have any pods or workloads running in this new cluster. And we can also see if I say Velero backup get, there's no backup in this cluster, and Velero is not installed in this new cluster. Now for this new cluster, we've already created a credential file for Velero, so I can go ahead and run the Velero install command again. This will go ahead and install Velero to our cluster. And if I do Velero backup get now, you can see there's no backups in our cluster. This is because Velero will start up, it'll look at our S3 bucket and pull down the backup objects that it finds in that bucket. And we can see if we run it a few times, there's still no backup. We can say kubectl -n Velero get pods, and we can see the Velero pod is up and running. And interestingly, if I say kubectl logs on the Velero pod, we can see that it started, it registered the plugin, and if we scroll down, we can see it found one backup at the location. So Velero has started up, contacted our S3 bucket, and detected that there's a backup there, and it's going to go ahead and attempt to synchronize the backup into the cluster. This does not mean it's going to restore the actual backup, but it's simply going to create the backup object. So if I say Velero backup get, we can see that it has gone ahead and synchronized that backup back down to our cluster. And if I do kubectl get all, it did not do the actual restore. So it's simply synchronizing and using the S3 bucket as a source of truth and bringing those backup objects down into our cluster, and then we can say whether we want to restore it or not. So the S3 bucket becomes the source of truth. So let's go ahead and do a restore. And similarly to a backup, it's just a one-line command. So we run Velero restore create, the name of the restore, and we say from backup and the name of the backup. So if I go ahead and run that command, this will go ahead and create a restore called default namespace backup, and it will run the restore from the backup that it's just imported. So I go ahead and run that. This will submit a restore request, and I can say Velero restore describe to describe that restore. And if I do so, we can see that the phase is completed. So it's gone ahead and restored that successfully. It has a start and end time. We can see it took 1 second to do the restore. It tells you what it could not restore. So in this case, because I'm restoring on top of the default namespace, it's not gonna go ahead and restore the endpoint Kubernetes, since that is the existing Kubernetes endpoint for the API server and the default service of the Kubernetes API server. You can also see that it excludes by default these objects, and it's included all other objects. So I can then say kubectl get pods, and we can see our pods have been restored. We can also see our deployment has been restored, our config maps, our secret, as well as our Kubernetes service. So this shows you how easy it is to do backups and restores and use this as a disaster recovery tool, a migration tool, or simply a Kubernetes upgrade tool. So that is Velero in a nutshell. Now I do believe that most folks use Kubernetes for stateless workloads. Now Velero also allows you to back up persistent volumes, so it has the capability to back up disks and storage as well. Now personally, I believe this would be quite tricky to cover in one video, since stateful workloads introduce quite tricky dynamics when it comes to storage. If you're interested in a persistent volume example, there is an example on the Velero GitHub repo, but let me know down in the comments below if that's something you're interested in. Also check out the link down below to the source code and make sure you give it a try. And let me know down in the comments below, how do you deal with Kubernetes upgrades, migrations, backups, and restores? And remember to like and subscribe and hit the bell. And check out the link to the community server down below. And if you want to support the channel even further, be sure to hit the join button and become a member. Now, as always, thanks for watching, and until next time, peace.